Bismillahirrahmanirrahim. Assalamualaikum and good night to all of my friends. Thank you for joining the group discussion tonight. So today, for tonight, we are going um, to give give tasks
discuss.
to each other. So basically, we have three things to do, which is telegrapher's equations, telephonist equations, and to do conclusion about lossless and lossy transmission lines. So for telegrapher's equation, we have divided to two, which is for lossless and transmissions, and same goes with the telephonist equation, which is for lossless and lossy. Okay, you got that. So
Yes.
so who wants to do which one? May I volunteer first?
Okay, I want to do the first one.
I want to do the telephonist equation.
Okay, Amni, telephonist.
Which part? The lossless or
lossy
lossy
or
I'll do the telephonist for lossy.
telephonist for lossy.
Me
Then
telephony lossless.
okay. So Aina will telephonist lossy. Which one? Amni lossless or lossy?
Lossy.
Amni lossy
Lossy.
and Aina lossless.
Lossless.
All right. So I will take the telegrapher's lossless. Is it okay?
Okay.
Then I take the lossy. Telegrapher for lossy.
So then you will do the lossy
Yeah.
for telegraphers. So that left Rufaidah for the conclusion. Is it okay, Rufaidah?
Okay.
Okay, nice. So everyone.
But we need to mention our name at our PDF, right? Mention
Yes.
our name on each paper or our own paper that we do.
I think
which part?
maybe
Yeah.
we can do that. Just we can put our
okay.
name and number on the paper. So everyone will do their part. So do you want to do another discussion after we have gained the information?
Actually, what information that we are going to find?
Yeah.
What kind of information?
The equation and of the history or how to calculate the equation.
Oh, yeah.
Something like that.
How
I'm not sure.
Or you asking?
I mean, we get the equation, right?
Yes.
Then we need to find the history of the equation or something other information for the equation, or we just get the equation.
So I thought that we just need to get the equations. I don't know.
Discuss the difference.
How?
Yeah, that one is for conclusion.
Yeah, conclusion you have to differentiate.
I think
for conclusion, I need to differentiate the two differences.
And also you have to find the similarity.
Similarities.
Okay.
But
So
for
we
us,
need to find
Okay,
the
for us, I think
characteristic
yes, the characteristic.
yeah.
What for the equation? Yeah.
In what condition we need to use the equation?
Yes.
Then the conclusion can compare.
or maybe we can insert an example of question.
But Toto say no one example, right?
I'm not sure.
Okay.
I'm not sure.
I'm not sure too.
Do we have like
It's okay,
restriction in our PDF? Like how many pages?
Oh no.
No.
Doctor doesn't.
Yes.
But I'm not sure about the example can give or not. Right? Maybe we can ask another group, another cosmet.
Yes. Sure. So for now, find the equation and the characteristic.
Yeah, in what condition need to use the equation?
Okay. Assalamualaikum and good night to everyone. Thank you for joining our group discussion tonight. So tonight we are going to discuss a little bit, just a bit about our task. So we can start with Aina first. Okay.
Hi, hello everyone. Okay, I'm doing the part of lossless telephonous equation. Okay, I found that actually this equation was generated by the previous telegrapher's equation. Okay, as you can see from the screen, okay, telephonous equation for the voltage, d squared v over dz squared equal to minus j omega l di over dz. Di over dz you substitute with negative j omega cv, so equal to minus omega squared l cv. For the current, double differentiation of respect of dz squared equal to minus j omega c dv over dz. dv over dz you substitute with minus j omega li equal to j omega c, j omega li equal to minus omega squared lci. And there is a general solution for the voltage equation. V equal to V plus exponential minus j bz plus V minus exponential j bz, where the wave propagation constant is beta equal to omega square root of LC.
Okay.
Okay. Next, Amni.
Okay, next, my part. I'm doing lossy telephonist equation. The terms for this telephonist lossy equation is but it has some difference in formula. So for lossy circuit, you can see here, it has a series impedance which is LDZ and RDZ, and a shunt admittance which is CDZ parallel with GDZ. So series impedance is a function to determine the variation of the voltage from input to output of the cell, while the shunt admittance is used to determine the input.
Okay.
Lossy telephonist equation is actually a set of uncoupled equation. It is called uncoupled equation because exact. So like Aina equation, for this, if you see the substitution of di over dz is quite different, where for lossy it has plus g, and for the dv over dz we have plus r at the back. So the propagation constant for lossy is in complex quantity, where the alpha is equal to 0. Hence, the characteristic impedance is in complex quantity. That's all.
Okay. Continue.
I'm doing the lossless telegrapher equation. The telegrapher equation is a pair of equation. One is talking about the V and one is talking about the I. So we combine two equations, then we get the partial differential equation. In the lossless transmission line, and the R and G equal to 0, so we can ignore straight and get the equation, get the equation for the lossless transmission line. Then after simplify, we can straight get the telegrapher equation for lossless. It is dV over dx equal to j omega L I, and di over dx equal to negative j omega CV. We also can express it and in the sinusoidal steady state, which mentioned in the PDF also. That's all for me.
Okay. Okay, next one, Amir Faris.
Okay, for the telegrapher's equation lossy, actually, it is actually the same. That's the same with the telegrapher's lossless, but the only difference is lossless. In a lossless condition, we can neglect the R and G, so that uh, the telegrapher's equation will be shorter and simple to handle with. But in the lossy condition, we can't ignore the R and G. So that's why to that's why we using the lossy condition will be a lot easier for us to solve question for telegrapher's equation. Okay, that's all.
Okay, next one, we have come to conclusion. Okay, first of all, I've made a table for us to see the difference between telegraph lossy, lossless, and telephonist lossless and lossy. So from this equation, we can see that telegraphers is the first derivative, first order differential equation, while telephonist, we have second order differential equation. Actually, we can get the telephonist by double differentiate the telegrapher's equation. And then if you see here in this part, the telegrapher's equation only consists of either L or C component. This is because I'm sorry. When in lossless we have either L or C component, but in lossy we have an additional of R and G. This is because the lossless, we can neglect the R and G. R and G is equal to 0, but in lossy, R and G is not equal to 0. So, okay, then the telephonist, we have both L and C component as well as the R and G component for lossy telephonist. Then we can make an equivalent circuit for both lossless and lossy. We can see the lossless we only have L and C component, while in lossy we have all 4 components in the circuit. And so lastly, I'll say that after the lossless, after we've seen all the lossless and lossy, we can say that because of we can neglect the R and the G component, the characteristic impedance for lossless is equal to only the real parts, which is the square root of L over C. And for the lossy, we have this
Equation.
we have this, which is become a complex form. We have real and imaginary part also. So I think that's all.
Okay.
You guys have anything to share?
I think that's all.
I think you have a good explanation, Rufaidah.
Yes,
Thank you.
Yeah, good job.
I've got the whole concept already.
Yeah, I can finally
What is telegraphers and also telephonists? Actually, telegraphers come first and then telephonists.
Yeah.
Yeah. Okay.
With that being said, I think that we
Yes.
can end our group discussion for tonight. See you soon.
Thank you.
Thank you for your
Okay,
cooperation.
thank you, everyone.